Hello, today I'm going to show you how to reconstruct a PCB using Gerber files. So yeah, this is how to convert from Gerber files to a full PCB file. And then today we're going to show you an example here of the Gerber file. So this is going to be a power regulator using the DC to DC converter, which will output a stable 0.85 volts. So over here you can see I've opened the CAM document, and yeah, and then now, so we're going to import the Gerber files, and then for reference, these store the shape location data for all elements, and each layer is going to be placed into its own Gerber file, and then the NC drill files, which I'm also going to import, convey the drilling and routing information. And yeah, you can see that those are needed to reconstruct the board. So now, yeah, we've just imported all the files, and next, as you can see, yeah, we have all the files over here. Now we're going to need to import the drill files, since, again, like that's the drilling and routing information, and we'll need it to complete our PCBDoc here. So as you can see, yeah, we're going to import drill data, just all the usual presets should be fine. Alright, so as you can see, we have all the layers there. And then next, what we're going to do is extract the net list. So first of all, we need to make sure, yeah, that we have all of our layers defined. So before we do that, the most important thing is to assign all signal layers a type. So these either have to be top, bottom, or internal, temporary files as well, based on their place in the original PCB. So what I'm going to do over here is change like the pad's bottom and top layers to temporary, and then, for example, change this layer to mask bottom, and yeah, that should be good. And after that, we're going to have to define the physical ordering of the layers, and usually only the signal layers are going to make it to this pop-up screen, so that's all we have. So yeah, just separate that from logical order, and then we should be good to go. And then all nets of the PCB have been extracted, where net 0 is a filled ground plane, and the rest are going to be highlighted on the PCB, sort of by the Camtasia viewer, as you can see there. And yeah, this is just showing sort of different views. And again, just kind of going layer by layer, looking at each of the pieces and then each of the nets. So yeah, you just saw net 0, and then everything else you can immediately see. And the next overall step, yeah, that we're taking here is to export to PCB, where we're going to try to get a PCBDoc file generated with 2 different layers. And the reconstruction's not done, however. So we're going to need to do some manual cleanup with polygons. So there's sort of empty polygon and copper pores, which we must fix manually. So we're going to go to Polygon Actions, and then go to the Polygon Manager. And then, as you can see, here are all the individual layers, right? And you can see, yeah, that we have the top layer, sort of with, yeah, like the most overall area, and therefore it would need the most work. So we're going to move that all the way to the bottom. And then generally just continue to physically reorder the pour order, where we pour manually the smallest polygons and the largest are last. And then this ensures that the smaller polygons will not be erased by the larger surrounding ones. And yeah, as you can see, we've been clicking up layers and moving it up or down depending on the size. And then once we finish and have the correct order defined, what we can do is re-pour the layers. And then, yeah, open the pour manager to verify that they're poured in the correct order. So as you can see, here's our bottom layers. So we're going to need to move, this one layer that was at the top all the way to the bottom over here, such that we're pouring the largest polygons last in this case. And then there we go. We just have to continue moving up, and then, yeah, this process is quite manual and can take quite a while to complete. But then yeah, eventually, as you can see, now we're at the stage where we're able to select and then re-pour everything. Again, back to the Polygon Manager one more time just to make sure that we have everything in place, all the different nets are correctly formatted. And then yeah, we clicked OK, and then now yeah, we're gonna have to focus on re-adding the footprints now. So yeah, now we're gonna go over to our files, downloads, and then come over to the schematic. So now that we've fixed the polygon pores, the PCB is good. Now we're ensuring that we have all the footprints correctly. So this way, by looking at the schematic, we can get all the necessary serial numbers, that kind of thing. And generally, yeah, that comes of great benefit, because then we can just look those up and then manually add the designators and place them. And then yeah, I'm just gonna rotate them, and then now you're gonna see a time lapse of manually rotating and adding all the rest of the components. But yeah, as you can see, we have the footprint, and we're adding those according to the outline. So again, you must have the components and associated footprints saved to the component library for this to work. And with all the parts available, you just right click on the board, place component, search for the part, as you can see, and then drag and drop, and repeat the process for the remaining components, as you can see. So for the capacitors, for the header, and then for the chip, we're going to continue to do this. So as you can see, we're nearly done here. And then the next step is after this, we're going to end up deleting the generic designators which were given, as you can see over here. So yeah, first we'll just start by looking over here into the 3D view, and then now you can see we've deleted a lot of the generic designators now, and then you should be able to view the board in 3D mode now that we were able to very quickly fix that, as you saw in the time lapse. And now you can admire the reconstruction from the manufacturing file. So here's your completed PCB. Thank you.